Hey everybody, this is Miss Segovia and I'm going to walk you through your notes on transcription. You're going to want to have a little handout, this one with the nucleus on it, as well as the strip right here all cut out. You don't have to get real exact on the little points and divots and stuff, just kind of get it ballparky. That, and then you're also going to need your notebooks. So we're going to start out here kind of going back and forth between the handout and the notes. So let's start out with our title of our notes. And that is transcription. So DNA has to be able to send information out to the cell, but it can't leave the nucleus. So let's put that on here. Since DNA cannot leave the nucleus, and of course there is an exception to that, so let's just include it, except during mitosis, and then it gets all wound up and attaches to the the centromeres to the spindle fibers and all that. But since DNA cannot leave the nucleus except during mitosis, we use mRNA to make copies of our genes. Remember, genes are those segments of DNA that code for a particular protein. And so there's a complicated process, and I'm going to make it relatively simple, although it's going to have a few higher level things because we're pre-AP, and if you come back to me in AP, I want you to know these. So let's do step 1. We have an enzyme known as RNA polymerase. One of the ways we can identify it as an enzyme, it has ACE as its last name. It locates and then begins to unwind and open the segment of DNA, that contains the gene. So there's a gene in here that we want to make a copy of, and we don't copy all our genes all the time because why? That's dumb. We only copy the ones that we need. And so you'll have this little segment right here. So imagine this is a great big long DNA strand. If you want to make it all windy and stuff, that you can. But somewhere on that strand is a gene. Let's say it's just right here is the gene that we want. So our little RNA polymerase, I like to draw it as a teardrop shape. I don't know why. I guess the way I was trained. It's going to locate and it's going to find that little segment of DNA, and it's going to start to unwind it so we can do step 2. So in step 2, RNA polymerase reads the DNA on the opposite side. This is what we call our template strand. Of the gene we want. We actually call that gene that we want our coding strand, because that's really the code that we prefer, but we can't copy that one directly because the way the A's and T's and C's and G's match up. So we actually copy it on the opposite side, which is kind of a cool little mechanism. So when you see sketches and drawings of that, you'll have your little DNA strand. It'll actually be kind of opened up. And you'll have all your little nucleotides sticking out, hanging down. So those are my A's and T's and G's and C's. And since these hydrogen bonds are kind of weak, we can split it open pretty easy. And that's what the RNA polymerase does. And so we'll watch RNA polymerase go and read along here, because this is the gene side. So here's where my gene is, which is my my coding strand. And down here we're reading our template. And so it's going to start traveling along this strand and checking out what we got. And so in step 3, right here, is RNA polymerase moves along the DNA. It creates an mRNA strand. And so we'll have kind of a similar little sketch here. And you can make your sketches as detailed as you want. Sometimes it helps to have your drawings, because if you don't really want to read the words, but you just look at the pictures, you'd be like, oh yeah, that's right, I remember that. That wasn't so bad. I survived it. So I'm going to draw my little RNA polymerase, having moved along here a little bit. And as it's moved along, it's created another strand. I'm just going to draw that one a little bit darker so it kind of stands out, and those should be matching up. This little strand right here is my mRNA. And so I want to go back to the little worksheet that I gave you guys, and that is this one right here. So we can see this whole process is taking place in the nucleus. And this process, again, by the way, is known as transcription. You remember, there are two processes of transcription, translation. The letter C comes first. This right here, is this my DNA or my RNA? Well, let's take a look at it. Let's see. Oh wait, that first one, that's thymine. So that tells me right there, anytime I see a T, that this is my strand of DNA. And here we got a little RNA polymerase getting ready to move along, and we're going to code this strand right here. And so that's where your little cutout comes in. So what you're going to do is you're going to match your cutout with the DNA strand and fill in what corresponding RNA would join up with this. So thymine is always going to bond with adenine. So you would write adenine right here. And then adenine in DNA binds with thymine. However, this is RNA, and so instead of thymine, it's going to bind with uracil. And so if you want a little reminder of that, in DNA, A bonds with T and G bonds with C, but in RNA, A bonds with U and G bonds still with C. So the big difference is just instead of writing thymines, you write uracils. And I'll tell you, when you guys take like STAR tests and stuff, they like to mess with you and give you a strand, and you have to figure out if it's RNA or if it's DNA. So the big thing there to look at is whether it has thymines or uracils. So right here, cytosine would bond with guanine. There's another cytosine, so that means I've got another guanine. And you would just go on here and match all these guys up. And so on the bottom here, again, that strand that we're creating using the DNA template, this guy is an mRNA strand for messenger RNA. And then you've got these two little tabs right here. You can take a scissors and cut these guys. And probably the easiest way to do that is to just real gently fold it in half, and then take your scissors and make a little snip, and then you can cut that line out a little bit longer. I'm going to do this other side here too real fast, and then we'll come back and finish our notes because we got just one more step to do. Boom. Alright, so to do, the reason you do these is so you can take this guy, when you have him stored in your notebook, you can put those two tabs in, and then he stays right there. Isn't that clever? And then you can take this guy and you can glue him in on the opposite page, just making sure you don't put any glue where the tabs are. Alright, so let's finish our notes. One little segment left on this one, and then we'll move on to translation in the next video. Okay, so we're going to go through and we're going to pair all the A's with T's, G's with C's. And in step 4, the RNA polymerase detaches, means it lets go, it releases the DNA, goes back together, and that, by the way, is courtesy of those awesome hydrogen bonds, because they kind of act like little magnets and they stick together. And the mRNA exits the nucleus for the next step, which is translation. Sorry, there we go. Translation. And so to draw that one, look at this, perfect. We just got a little tiny bit left at the bottom. I would draw my little DNA snap back together. Remember, DNA is like crazy long, and so we're just showing like a little piece of that. So this is my DNA. My little RNA polymerase, he's gonna let go. But then my cool little mRNA strand, which is single-stranded, by the way, not an awesome double helix like our DNA, it's going to exit our nucleus. So I'm going to draw my little nucleus right here, just kind of imagining that's a big circle. And so in here is the nucleus, and out here is our cytoplasm. And eventually this little bugger is going to meet up with this cool looking spaceshipy dude known as a ribosome. But that is in our next part. So folks, that is in a nutshell what transcription is, where we take our DNA strand, it gets opened up by RNA polymerase, we create a strand of mRNA, and then the mRNA strand can exit the nucleus to meet up with the ribosome and do part 2, which is translation. So get that all put in your notebook, get this guy glued down, except for this piece, because we're actually going to use this again when we do translation. Let me know if you have any questions. Thanks.